Perfect. So today we have Maryam Bostanara presenting on the modeling dynamics of behavior of people. Maryam is a first-year PhD candidate at rCITI at UNSW under the supervision of Taha Rashidi. She received her bachelor and master degrees both in industrial engineering from Sharif University in 16 and 18. And before starting her PhD, she joined rCITI as a research assistant for 8 months. And her research interests include data analysis, transport modeling with statistical and optimization tools. So Maryam, it's up to you. You have about 20 to 25 minutes to present your research, and then we'll jump to questions.
Thank you, David. Hello, everyone. My name is Maryam, and I'm a first-year PhD student supervised by Associate Professor Taha Rashidi. My research topic is modeling dynamics of behavior of people with a Bayesian survival approach. Today, I am going to very briefly introduce our research during last year. As it comes to modern society, the way people make their major long-term decisions is of great importance, as such decisions affect society from different aspects. Households make decisions on their residential location, vehicle ownership, occupation, education, and many aspects of their intra-household. Although observing the people's long-term decision may seem very intuitive, it is indeed very complex, as there are many interdependencies among them. For example, a person may change his home based on a decision on changing his household structure, for example, getting married. And following this change, he should probably decide on acquiring a vehicle to commute. As a result, taking only these 5 variables into account makes the system very complex. As you might have also noticed, there are many more variables that can be added to the model to increase its efficiency, but they definitely increase the model complexity even further. So clearly, understanding the behavior of people on long-term decisions and their interactions is of great importance, not only in transportation and urban planning, but also in many different fields, such as vehicle and housing market, geography, and economy. There are ample research studies on modeling the household's behavior and their decisions on durable products. Needless to say, the human mind has a very complex structure, and so has the process of decision-making. So clearly, no study has so far been able to get a clear understanding of the dynamics of people's behavior. On the other hand, realizing the aspects that affect humans' decision-making is not easy either, as the society and humans' life are very complicated and their complexity level is dramatically increasing, particularly over the previous years. Therefore, we are in need to gain a deeper knowledge of the dynamics of behavior of people, so that we can gain a better insight into transportation and economics studies. As a result, a framework for the behavioral modeling, which considers the mentioned aspects simultaneously, will significantly contribute to the field and enables generating new knowledge about the dynamics of people's behavior. Looking at households as the decision-maker units of the society, we can categorize the household's long-term decisions into their choice of occupation, education, vehicle, and home ownership. The decision-making process of each of them may be shared, unshared, or somewhere in between. Not only these decisions may be interrelated, but also each has some sub-decisions need to be made, such as which option, when to change, and why. To model the whole decision-making process and each sub-decisions, we are using a number of tools, namely survival analysis, discrete choice modeling, machine learning algorithms, dynamic programming, narrative economics, and Bayesian statistics. Very briefly, survival analysis studies the duration that an individual has spent in one specific state until a certain event happens. Taking the example of residential relocation, survival analysis studies the duration of keeping home until moving out. What makes survival analysis different from other statistical methods is something called censorship, which in the case of this example simply means not all households in our study have moved out from their current home location, and we don't know how much longer they intend to stay there. To briefly introduce Bayesian statistics, imagine we are interested in knowing the impact of job change on home relocation. To answer this question, a frequentist statistician may collect data from population and then develops a model and calculates the point estimates for the model parameters. However, a Bayesian statistician not only collects data, but also takes prior data collected from previous results into account and calculates the parameters posterior distribution. So why Bayesian statistics? Because this perspective is nearer to the reality, and also even in the case of lack of prior data that we use non-informative prior, Bayesian statistics enables us in making many different inferences and which are more interpretable. To do experiments on real-world data, we could use well-known HILDA dataset, but as we needed some information that was not included in that, we are using a residential data collected from Chicago and Sydney. And this picture shows the frequency of respondents' postcodes in these two cities. In this survey, respondents were supposed to provide information about their previous and current residential locations and to give some information about people they are living or were living with. Also, they were required to give some information about all members' occupation, education, and vehicle ownership since they moved into their previous home. The survey also inquired about the typical travel mode people choose for different trip purposes, including commuting, shopping, recreation, and studying. During previous months, I have been working on a few projects, and here I am going to introduce each of them. The first project was a study titled A Comparison Between Residential Relocation Timing of Sydney and Chicago Residents with a Bayesian Survival Analysis. In this study, a survival model with time-varying covariates were generated, which was run under both frequentist and Bayesian approaches, and the residential relocation timing of Sydney and Chicago cities were compared. Comparing two cities' parameters was much more efficient using Bayesian statistics, as comparing the posterior distributions is much more precise than comparing point estimates. Clearly, not all covariates are or can be regarded as constant variables during the time. For example, number of household members, income, vehicle ownership, and occupation may all change during time. So incorporating time-varying covariates has a significant impact on the model accuracy. In this study, after preparing data and determining the formulation, the likelihood functions were calculated. And then the model was run under both frequentist and Bayesian approaches with different sets of covariates until reaching a final model. The frequentist model, which also can be seen as a classical survival model, has three main functions, namely failure, hazard, and survival functions. So the likelihood function of the AFT survival model with time-varying covariates were calculated by Weibull distribution survival and hazard functions, and it was maximized. Regarding the Bayesian statistics model, not only the mentioned log likelihood were used, but also uninformative prior distribution for each model parameter were defined. And then samples were drawn from the posterior distributions using MCMC methods. In the end, running the Bayesian model was computationally easier as the process of likelihood maximization was eliminated. Also, the results of the Bayesian model were more interpretable and easier to make inference on. In addition, although the significant variables in Sydney and Chicago were very similar, they were not exactly the same. Moreover, the variables' overall accelerating or decelerating impact on residing duration agreed in both cities. However, the amount of their impact was different. In this study, many variables were observed to have impact on residing duration. And now I am going to mention some of the observed people's behavior. First one, as the master of household gets older, they are less likely to relocate. And second one, households with more children under the age of 18 are likely to stay in their home longer, especially in Chicago. Households with a remote working member, I mean a member who works from home, are likely to stay in their home 1.5 times longer than others in Sydney. As results suggest, an increase in a household's income has an accelerating impact on the residential relocation in both cities. Although an increase in rent has an accelerating impact on home relocation, especially in Chicago, increasing the mortgage decelerates the residing duration. People living in a house are shown to keep their home 4 and 2.5 times longer in Sydney and Chicago, respectively. And regarding the intra-household decision-making procedure, the more a family makes shared decisions on investment and large household purchases, the more they postpone their relocation, especially in Chicago. Owning a driving license increases the household's stay in one location, especially in Sydney. And finally, regarding the life course variables, looking at the number of jobs changed in a household during the last year shows that changing job decelerates the home relocation process. And households who added a child to their household in the last year seem to reject a new major change, such as home change, especially in Sydney with a time ratio of more than 4. This study has much room to be enhanced by implementing more complex models, such as modeling of simultaneous decision makings and reasons behind them. Also, in this study, a Weibull baseline was utilized, but as can be seen in this figure, more complex distributions, such as log logistic and log normal, fit the Kaplan-Meier survival curve of the data much better, and thus implementing them will enhance the accuracy of the model. In the second project, titled Residential Relocation Timing of Classified Sydney and Chicago Residents with a Bayesian Latent Segmentation Survival Analysis, an AFT survival model with latent class methodology were utilized. In this study, the model fit was enhanced by letting model classify the individuals into multiple groups and run different duration models for each group separately. A small study were also done on people's preference to change their home first or their job first. In this study, a group of respondents who had changed their home in a time window of 1 year prior to or after home relocation were selected to train a logic model for classifying the observations. Then by the estimated logic parameters, other observations' probability to be included in each preference class were calculated. And in the end, a survival model was utilized to estimate the relocation timing of each observation based on how much they belong to each group. The third project was on a residential simulation model on Sydney metropolitan area with a classification method. The residential data were converted into yearly database and life course variables were extracted. Then a classification model, supervised learning, which is based on logistic regression, was run to classify the yearly information into moving out and stay groups. The results of this study shows that when feeding the model with only uncensored data, the model can detect the moving out year of the household with more than 88% accuracy in both cities and also both train and test sets. However, when feeding the model with both censored and uncensored data, the model accuracy for detecting the moving out year decreases. So the model can only detect nearly 50% of the moving out years correctly. The results of these studies have submitted to Computers, Environment and Urban Systems Journal in September 2020, and now the paper is under revision thanks to Taha, Joshua, and Mila. Also, I plan to submit both classification and latent class model research results in 4 months. Thank you all for your attention. If there's any questions, please let me know.
Thank you, Maryam. Questions from the audience, students in particular?
I have one.
Yes, you go, Mia, you start.
So thank you very much, Maryam. Very interesting. Well done. Very clear presentation. I really liked it. Maybe I missed at the beginning. What was the data set that you were using? Is it a specific survey that you have done, or is it coming from some census type data?
It is data that Milad has collected during his PhD, I guess.
Okay. How many participants from Chicago and how many participants from Sydney?
Around 500 in Sydney and 450 respondents from Chicago.
And do you know what time window the question were asked? Like, when was the last time you moved, or what kind of questions and in what time frame?
The time frame was, the questions were asked in, I guess, 2018. But each person were required to give information about their previous and current home location. So there was not a very specific year for the respondents. For example, we had some people who had who gave information about their previous home, which were in 90s, and some people who had moved in the previous year. So.
And how did you, when you do hazard-based modeling, how do you deal with left censorship and right censorship in the data? Did you have those issues? Do you know about them?
We didn't have issue with left censorship because we knew all the information of the timing, but about right censorship, actually half of our data is censored because we don't know when people move out from their current home location. So to deal with that, we use survival models, which they are actually built for that. They can account the censored data.
There is another data set. I'm not sure how comparable that would be. It's an idea. It's not a question or even a comment. You know how Australian census, they have, when you ask every census, they ask this question that, where you living in the same place 5 years ago, or maybe a year ago. I'm not sure how many years they ask, but of course, in the data, we don't have individual people data moving, but we have the, for example, SA1 to SA1 movements. For example, how many people moved from this SA1 to the other SA1. It would be interesting to see. I'm not sure how, I don't think if survival analysis can be done on that, but other types of analysis, mainly network-based analysis, can be done on those kind of house relocation. But anyways, it was just an idea, nothing for you to address.
Thank you. It's very interesting. So
well
I will contact you to find more about that. Thank you.
Cool.
Do we have any other question from the audience? You can write them by chat if you prefer. Okay. We do have time, so really, if you have questions, don't hesitate. Otherwise,
I can ask another one.
okay, thanks, Liad.
So in terms of the representativeness of the data, because I assume one application of your model is use that model in agent-based model, activity-based model, where you want to see how land use changes in, let's say, 10 years or 20 years from now. Do you know how representative the data was, and also what other limitations do you see if somebody wants to take your model and use it in an agent-based model for prediction of land use changes in 10 to 20 years from now?
That's
Difficult question, huh?
hard question. I have not, honestly, I have not thought about using this model for any prediction for future so far, but in the third project, this one, we are planning to use the results for simulation for the land use to see how the household relocations can be modeled and be how to say that. Yeah, we want to simulate the results of this study to see how households relocation can affect other aspects such as land use.
Mm-hmm. Cool, that's good. Thank you.
Yeah, I might be able to actually address this one because I was involved in the data collection aspect of the project. Because the data was collected by a market research company, both in Sydney and Chicago. We had a specific quota for age, gender, occupation, education, and we matched them based on even a spatial distribution. For Chicago, we received some specific requirements by Argonne, and they asked us to also match some special distribution of people in Chicago area. So before starting the data collection, we matched some of them, some of the socio-demographic attributes of the population, but definitely not necessarily many can be matched with this small sample.
And one thing else, another thing maybe for Maryam and Taha, you know how, what was it called when people move out, where people are forced to move out from a suburb? What was it called? Because of like socio-demographic changes or house prices go up or down. Gentrification. So we know how gentrification happens because, the demographic or the house prices change. Do you see some of these survival analysis models, are they able to capture the impact of gentrification when you want to use it for prediction? Or what kind of socio-demographic and house price related indicators feed into these models to be able to capture some of these effects in future?
We haven't looked at that in Maryam's research, but before using Hilda, what we've done was to look to consider the reason for relocation. And different reasons for relocation can compete with one another, and simultaneously these causes specific models, we call them, they can any of these causes can force the person to relocate. For example, using Hilda, we looked at financial reasons, demographic household specific reasons, and upgrading or home specific reasons. So people, because of different reasons, they may decide to fail. We can call them failure, which means survival ends and people decide to terminate staying at one specific location and move out. So this might be one reason, as long as it is stochastic. If it's deterministic, meaning that if that happens, then something should happen. So this is not anymore stochastic. We can just with one rule can determine it. But if it's stochastic and it's competing with financial situation of the person, something else maybe is offered elsewhere in another suburb, then that can be integrated into a competing hazard model, so that the reason of, or the reason can be also simply included as an explanatory variable.
Does the model also distinguish between rent and ownership?
Yes, I'm in this model now, but we've developed separate models for owners, renters, or a joint model in which owner tenure of ownership is an explanatory variable. It's better to have separate models specifically for owners and renters, because the duration is significantly different for them. But if we don't have enough data, we can just simply include it as an explanatory variable.
Well done. Can you predict when will be the next time I will move?
Next year, 2021.
Thank you very much. Good to know.
Right. So moving on. Thank you, Maryam. Thank you very much. Last chance from the audience to ask a question, and otherwise we'll see everyone next week for the last seminar of the year. So thank you, Maryam, for your time today. Thank you for your presentation, and have a good week.
Thank you.
Thank you. Thanks.